Guys, this video is on how to find the least common multiple. This is a useful technique when you are working with two fractions that do not have the same denominator. So let me show you what I'm talking about here. Okay, so we're looking here at 3 1/2, and we're adding 1/5. And as you can see here, I've drawn a representation to show 1, 2, 3 wholes plus 1/2. Okay, now looking over here, I'm trying to add 1/5. Now, as you can see, the size of the pieces are different. Okay, so it's gonna be, if I take this piece and I squish it over here, I could do that, but I'm not gonna be able to tell exactly how much of this one hole is being filled up. I can get a rough idea, but I won't be able to tell exactly how much this 1/5 is when I squish it over here into the 1/2. So what we got to do is we've got to use some sort of technique to help us out. Could we turn these big pieces and these small pieces, could we find a piece that they both share that we can easily turn this into and this into? Well, yes, there's a strategy called LCM, or least common multiple. We can use our knowledge of multiples to find a piece size that this and this both share, okay? So I know I've talked about how to find LCM before, but this is just to help you out in case you want a refresher course. Okay, so here we go. I've written our 3 1/2 here, and I've written our 1/5 over here. Now down here, I took our denominator here, 2, and I listed it here, okay? So there's our 2, there's our denominator, and I put a little colon here. That's just a way to help yourself organize all the multiples. And I've done the same thing over here. I took our denominator 5, and I have listed out all the multiples, okay? So multiples, just to remind you, are skip counting, okay? So if we're skip counting by 2, we're gonna go 2, 4, 6, 8, 10, and obviously we could go on forever and ever, but I'm just gonna stop at 10, and you'll see why in just a sec. Here, we're skip counting by our denominator here, which is 5. So we go 5, 10, 15, and again, we could go on forever and ever, but I'm gonna stop right there, okay? Because we already have a common multiple, a multiple that's the same amongst both halves and fifths. And you can see right here, it's 10. Can you see how they both share 10? And if we look, this is the smallest number that they both share. Does that mean that's the only multiple that they both share? No. They share a lot. For example, 20, we could make them 20, or 40, they both share 40. But we don't want to convert them to 20ths or 40ths because that makes our fraction a little bit too big and it's not going to be in the simplest terms. So that's why we use the least common multiples, because we don't have to make it any simpler, okay? It's as simple as it's going to be. So we're going to pick our 10 here, we're going to pick our 10 here, and that's going to become our new denominator. Or another way to think of it is it's going to be the size of our pieces. Our pieces are going to be tenths, okay? So what I'm going to do is I'm going to take our pieces up here, and I'm not going to cut them in half anymore. I'm going to cut them into our new piece size, which is tenths. We're going to do the same thing here. 1/5, I'm going to take those, I'm going to cut them into our new piece size, which is tenths. So, oh my gosh, can you see that? Good Lord, look how tiny our pieces are. See, I've taken these and I've cut them into teeny tiny little tenth pieces, okay? So again, we have 1, 2, 3 wholes, and then we still have half here. We're just calling it something different, okay? And if we counted all those up, it's gonna be 5. 5/10 can fit inside of this, okay? And we did the same thing here. I actually made this a little clearer for you to see, but I divide this into tenths, and the number of tenths that can fit inside of this portion is 1, 2. There are 2 tenths that can be fit inside of there. Now, a way that you can do that instead of drawing it out is you can use multiplication. Okay, so what we can do is we can ask ourselves, what number did we multiply 2 by to get tenths? And what number did we multiply 5 by to get 10? Now, answering that question is going to make our new fraction, okay? Now, we multiplied our fraction 2 by 5 in order to get 10. So that's the factor that we're going to use. Let me go ahead and write that down. We're going to multiply this by 5. Can you see that there? Okay, so that's going to give us our new denominator of tenths. Okay, now you have to be very careful because when you're doing this, whatever you do to get your denominator, you also have to do to get your numerator. Otherwise, your fraction is going to change. You're not going to have the same fraction. It's going to be completely different. So we're going to go ahead and we're going to multiply our numerator by the same exact number, by 5. Okay? So when we multiply our denominator by 5, we get 10. When we multiply our 1, our numerator by 5, we're going to get 5 tenths. Our new fraction, not 1/2, is going to become 5 tenths. Now you probably know already 5 tenths is the same as 1/2. They're the same. They're equivalent fractions. And this is a strategy that we can use to find as many equivalent fractions as we want. Okay? So going back down here, we're going to do the same thing. Now be careful. We're not going to multiply this by the same number. We're not going to multiply it by 5. That's going to give us a different fraction, and we don't want to do that. So we're asking ourselves the same question. We're trying to make tenths here. So what are we multiplying our 5 by in order to get 10? That's right, we're multiplying it by 2. Okay? We're multiplying by 2 to get tenths. So I'm going to go ahead and draw our new fraction bar here, our new equivalent fraction. Denominator is going to be 10. Okay, and again, be careful. Whatever you do to the bottom, you must do to the top. Okay, because otherwise it's going to change the fraction. We're going to multiply our numerator by 2, by the same factor as our denominator. We multiply it, and our new fraction, we get 2 tenths. Okay? Now, if you look here, 2 tenths and 1/5, you know that those are equivalent fractions, okay? Because we can divide this by 2, we can divide this by 2, and we'll get 1/5, okay? That's a quick way to check if you have made this an equivalent fraction. Can you divide the top number by the same number as the bottom? And will you get your same fraction you started with? And yes, we do. Okay, so our new fractions are 5 tenths and 2 tenths. And remember, we had our whole number we're dealing with here, 3 and 5 tenths plus 2 tenths. Now we add those together easily. We're going to get 3 and 7 tenths. Okay? All right, so hopefully that video was helpful to you. Feel free to rewatch it or ask me if you have any questions. But until next time, toodaloo.